can't think as people do. The machine is different.
Being, what marvelous being! How gratifying! How gratifying!
I do, and thanks, Kate, for introducing the courses I teach. The highlight of my year is summertime, and I do teach this course out at Towns Harvest Garden. We're with some staff who I see here in the audience, and 13 students. We run a community-supported agriculture program where we grow food for people, and it's a wonderful experience. Today was the first day of our community-supported agriculture program, our CSA harvest. So between yesterday and today, we harvested mustard greens, arugula, mizuna, baby lettuce, radishes, rhubarb, pak choy, spinach, and chives, our list. Now, I know it's almost Memorial Day weekend, and so that means it's time for sweet corn and watermelons, right? But this is the reality of Montana. In fact, and this ties in maybe a little bit to Mars, every one of those delicious vegetables we harvested, with the exception of the chives and the rhubarb, involved some kind of plastic, some sort of plastic cover. And so that's what we will broadly entitle season extension. Greenhouses, high tunnels, row covers, plastic mulch on soil, the idea to retain heat, because we lack heat. Mars is a little more extreme than that. Mars has seasons, but the warmest month in Mars is still colder than the coldest month in Montana. So the temperature management is going to be a theme that we'll see in this movie, as far as, how would you grow food in a climate like that. But I think it's something we can relate to a little bit here. So that relates also to my research program. I do research on how many layers of plastic does it really take, and how do they pay for themselves in terms of the costs financially and energetically and sustainability-wise as well. Is it worth the trouble or not, or can we just get things from Utah or California, right? And so we think really deeply about those questions. But it turns out we can grow quite a bounty here in Montana with a little bit of plastic. And then there's another angle to that, is how do you coax the soil into providing the sufficient nutrients for those plants to grow in that kind of an environment? And you don't do it exactly by the California playbook, it turns out. So we have an extensive research program here into soil fertility as well, how to maximize the productivity of soils in these extended season situations where we've invested a fair amount of money in plastic to cover up and keep warm. So that's the gist of my research program. Before Kate even invited me to speak at this series, I was teaching field crop production. This was back in February. One of my students came to me and said, "Hey, Mac, have you seen this movie, The Martian? Could he do that?" And I hadn't seen the movie yet, and so I said, "Could he do what?" And I didn't know. Like, what is this great feat Matt Damon accomplished that everybody wants to know if he could do or not, And I don't want to spoil the movie for you, so I'm just going to hint at it peripherally if anybody hasn't seen it. You can go home and Google it like I did, and it's complicated. So yeah, you could. And this is science fiction. This is a science fiction film. It's a good science fiction film. I've seen it now, and like any science fiction film, it's going to take a little bit of free license with details and facts and stuff like that, right? So not every detail of how you would go about growing a garden on Mars is going to be addressed here. If they did, it would be boring, right? If we had a documentary about perchlorate leaching and the Martian atmosphere and its composition and such, none of you would have watched the movie. You wouldn't be here. I wouldn't be here to tell you about it, and it would be terribly uninteresting, right? So I'm going to refrain, for the most part, from nitpicking the little details of what they leave out as far as scientific accuracy and is that really possible and could they really do that. If you've got questions along those lines, I'm happy to answer them after the film. And I'm not an expert on Mars, although I do have Googled a few things and read the Wikipedia article about the atmospheric composition, so I know a few things there, and it does present some genuine challenges. And I'll say this, as a soil fertility specialist, though, is that Matt Damon's unique approach to soil fertility in this movie is the least fantastic thing in the whole movie, actually. It's what everybody wants to know about, right? could you really do that? Will that work? Yeah, that will work. And in fact, I'll share with you a few stories about that angle. Dealing with the atmospheric pressure and what's in the soils already to begin with, and the lack of water and the temperature. Those things, in my mind, are all larger horticultural challenges. And I'm no astrophysicist, but I'm a scientist, and to me, some of the things that go on in terms of space vehicle restoration and crash landings and recoveries and things like this, those are all way more fantastic than any of the botany in this movie. So there's a theme in this movie, though, that I want to address, and I want to tie back into what's really important for the Bozeman Film Society and science and agriculture and Gallatin Valley Farm to School, and why we're all here this evening. How did I get to be here and be a plant scientist? I took advanced placement biology when I was in high school, did pretty well on it, took a couple other advanced placement classes. I guess I was a good student, and went in to see my guidance counselor, was going to go to college, and they said, "Oh, you passed calculus. You should be an engineer," right? And nobody told me about soil science. When I was 18, 19 years old, I did not know it existed as a discipline. I didn't concern biology was just like this foo-foo thing for people who didn't pass calculus, right? That was your fallback plan. And so here I am, and I did pass calculus and a whole bunch of other math, and I don't look at it as a fallback at all. In fact, it's what I want to be doing, and it's what I'm passionate about. And I really hope that through our efforts here and now at Montana State University's Sustainable Food and Bioenergy Systems program, through organizations like Gallatin Valley Farm to School, that we can communicate to our young people that botany is real science, and soil science is real science. And I teach a lot of students who come to my classroom who don't get chemistry at all until soils class. You sit through, who sat through chemistry class and left with confusion, right? But soils brings it back to life, huh? So I'm going to refrain from any technical details on the soil stuff, as I mentioned. I want to introduce you to a couple of books if you are interested in this topic of Matt Damon's approach to soil fertility, and maybe you thought that was novel, or there's a certain ick factor that maybe creeps into it from the cinematography or something. The first is a book called Farmers of 40 Centuries. This was published first in the year 1911, so over 100 years ago. The subtitle is Organic Farming in China, Korea, and Japan. So a man by the name of F.H. King traveled through those countries then, over 100 years ago, and he noted the high population density that was supported by organic farming methods, where every bit of organic matter was valued enormously. The labor that entailed in the farming that's documented in this book is extraordinary. And we are all fortunate, I think, to live in a time where the vast majority of us don't have to farm. Or for that matter, spend our days wheeling wheelbarrows full of muck or manure or human feces around to maintain the soil nutrient cycling that feeds us. We're fortunate to have synthetic fertilizers. We're fortunate to have industrial processes that manage our organic systems efficiently. And we all benefit from that. So we all, whether you're an accountant or a lawyer or a musician or an artist, are freed from the physical labor of moving organic matter around by hand to the benefit of all those other specialties in life. This is a really fascinating story. It goes into great detail about the population densities that are supported, the practices that are done. It's really fascinating. The other story, or the other book I want to mention, if you're interested in this topic, it's called The Human Manure Handbook, A Guide to Composting Human Manure. Don't take this lightly. Don't just go pick it up in the bookstore and read the back cover and go, oh, I'm going to go do this in my backyard. In fact, I distinctly discourage you from doing that, because we all do live downstream. So there are very good public health, safety reasons to be very cautious about this. But know that this is actually a really good book. It's very thorough, it's quantitative, it's analytical, and it outlines the risks and what you do about it to mitigate those risks. So if you want to take composting toilets very seriously, this is a great book to get. But know this, you don't have to do it yourself in your own backyard. We've been doing it and getting better and better and better at it for quite some time. So you can go down to your local big box garden center store and buy a product called Milorganite. So Milorganite stands for Milwaukee Organic Nitrogen. And it's a bagged product that's been for sale since 1926. The city of Milwaukee, Wisconsin was one of the first to recognize that what was a pollution problem in the Lake Michigan was also potentially a revenue source and a great sustainability boon. So they have been microbially digesting the solids from their municipal wastewater treatment plant since then and selling it around the country as an organic fertilizer for lawns and gardens. Now I say organic in the contains carbon sense, not in the USDA approved organic agriculture sense, because there's a unique story there in that under the current laws for organic agriculture, we're actually not allowed to use any composted sewage sludge or biosolids type products on an organic farm. And there's some good reasons for that and a little bit of debate about why. So things like pharmaceuticals, heavy metals in industrial cities, wastewater treatment programs are all issues, and there's pretty good science about those. And the organic rules simply draw a line and say, we're not going to do that. And I find that a little bit ironic, but interesting. So know this, though. If you were to go use the facilities here in the Ellen Theater right now and push the handle and away it goes in water on down to the Bozeman Municipal Wastewater Treatment Plant right there along the East Gallatin River, that they have world-class technology in place there that's going to take the nitrogen and put it through some microbial processes and release it into the atmosphere in a totally inert form, the same inert form that's composing nearly 80% of our atmosphere as it is. And they're going to concentrate the phosphorus, a lot of the carbon, and many of the other nutrients into a solid product that is spread on farmland in the Gallatin Valley to some extent. And some of it's also used as mulch products and a capping over the landfill. But it is used on farmland. It can't be certified organic farmland. And then they release water into the Gallatin River, East Gallatin River, and I'm told that's a good fishing spot. But the water does meet strict standards for quality as it goes back into the river. So we're already doing this kind of in a grand scale, and it's something that we don't really think about very much. So I guess that's about what I've got to say to start with here. Don't get too icky or queasy about the horticultural side or the soil fertility management side. It's very real, very feasible. Challenges otherwise in horticulture, as I mentioned, temperature, atmospheric pressure, much bigger issues actually in my mind. And I will turn it over to the movie here. It's a little over 2 hours, so we're going to be here for a while. And then I'm happy to entertain questions afterwards out in the lobby. Thanks again, and enjoy the movie.